Welcome to the second video in the set theory section, and we are looking at how we represent a set. And there are two methods for doing so. The first is called the roster or tabular method, and the second one is called the set builder form. Now, a roster or tabular is quite simple in the sense that you just have to put the elements within braces or brackets and nothing more ought to be done. Suppose we deal with a set C, and set C consists of multiples of 2 as 2 and between uh, 4 and 9 in such a manner that 4 is included. So we can see that such a set would be consisting of 3 elements, that is 4, 6, 8, and I have denoted the set C. Now, a very important point one has to note here is that the order of the elements is not important, in the sense that here it's written 4, 6, 8. If you write 8, 6, 4, there is nothing wrong in the representation. And more than that, second point is that repetition has no effect, in the sense that if you write 4, 4, 6, 8, when we consider the elements, only 4, 6, and 8 is considered. We don't take the repetition of 4 into consideration. That's quite important. So the order of the elements is not important, and also repetition has no effect. Now, coming to the set builder form, which in a manner is more important in the sense that the characteristic property of the elements is given a key importance. That is the property of the element. That is, when we are choosing an arbitrary element, which we call x, the property of the element, p of x, that is property of the element, and in such a manner that the property holds on. That is, the selection of the elements for a given set is based on the criteria of its property. That's because the property is holding on, or the property is there. We are choosing the elements. That's the meaning of it. So it's represented as x is such that p of x. So the slash or the two dots there, it means such that. So x is such that px holds. So that's how the representation is done in the set builder form. Let us look at certain simple, straightforward examples. I have denoted as a set E, which consists of even natural numbers. Now we know that natural numbers, that set starts from 1 and goes on to infinity. So naturally, how do you put it? I have denoted it capital E, and S is such that, so you are pointing out the property that x is an element of natural numbers. Of course, we are taking x from the set of natural numbers, and what is a specific character? Specific character is that it's a multiple of 2. So, and n denotes a particular number. It's in a manner an arbitrary number. So you are writing it as 2n. So it simply means that you have to point what n is belonging to. So n is belonging to capital N, that's a set of natural numbers. In fact, you can write it in a shorter form, that is, x is an element of natural numbers such that x is equal to 2n, where n is an element of capital N, that is a set of natural numbers. Suppose it's stated that you create a set, or a set of all real numbers greater than -1 and less than 1. It's quite simple. I have denoted the set S, and x is equal to x is an element of real numbers. So R, capital R, stands for the set of real numbers, and is such that, and what is the property? The property is that it ought to be between -1 and 1. So as -1 is less than, x is less than 1. Now, what if it's the other way around? You have been given a set C, which consists of numbers starting from 0 onwards, and you can see that it's 1, 4, 9. You can see that they are squares. So it's a straightforward case. The elements are already squares, which means that you can represent the element as a square. Hence, set C is x squared such that x is an element of z, that is set of integers. Now the point is that uh, must you denote it as is set plus that is so now is there any importance, or is it necessary to denote the whole thing as set plus, that is the set of positive integers? The answer is that it's not necessary, because in this particular case we will be, the squares would only be positive integers, unless we are also looking at the case of complex numbers, which we will be going into detail in the future videos. And there is a very important particular chapter dealing with complex numbers itself. And to finish off this particular and finish the discussion of this particular section, what about a set of reciprocals of natural? Now, reciprocal means if you are dealing with the number n, reciprocal means 1 by n. So here you have to highlight that particular character. So I denote it as capital N, and I have to point out that capital N, I choose N. It doesn't necessarily mean that as it is because we are choosing we are dealing with natural numbers. Capital N has been chosen. So capital N is an arbitrary chosen letter. We can put any other letter. The only point is that within the braces you ought to specifically point towards natural number. So set n is x is such that also key character of x, that's x is a reciprocal, that's x is equal to 1 by n, and n is an element of capital N, that's a set of natural numbers. You may further shorten it by putting the property first itself, that is 1 by n, such that n is an element of capital N, that's a set of natural numbers. Thank you.